Hello everyone, welcome to Coach Calculus, where mathematics stop being a problem and start becoming your superpower. If you are ready to make numbers bow to you, smash that subscribe button, like this video, and let's dive in together. Okay, as you can see before us, we have a question under number system, which says convert the following to base 10. A, there we have 11101.011 base 2. B, we have 3A. I explain further the meaning what this A stand for in the calculations. We have 3A, 5B base 12. C, we have 3, 4, D, 5 base 16, and then D we have B for F point A base 16. So without wasting much of our time, let's dive into the calculation. So, solution A says we should convert 1101.011 base 2, convert it to base 10. So I'll show you the step-by-step guide on how to go about this. Make sure you stick to the very end of this video so I can get the very best out of it. Now converting to base 10 from base 2, what we'll be doing is, because we're working in base 2, now we'll take this one here, write it here, 1, and then times 2. 1 times 2. And we'll raise it to power 1, 2, 3, 4, because we have 4 numbers at the back of this one, so we'll raise it to the power of 4. Then plus 1, this one again here, plus 1 times 2 raised to power, how many digits do we have at the back of this one here? We have 1, 2, 3 raised to power 3. Then plus this one now, 1 times 2 raised to power, how many digits do we have at the back of this one? We have 1, 2 raised to power 2, plus 0 times 2 raised to power 1, plus 1 times plus 1 times 2 raised to power 0, plus 0 times 2 raised to power minus 1. We write minus 1 because this 0 is after the decimal point, so the 2 will be raised to a negative index, which is raised to power minus 1. This value now plus 1 there's no need for me writing equal to here. Let's write your plus 1 times 2 raised to power minus 2. After the decimal point, we have 1, 2 raised to power minus 2, and then plus this last one here, 1 times 2 raised to power minus 3 raised to power minus 3, and then equal to this times this is 1 times 2 raised to power 4, that is 16. 1 times 16 plus 1 times 2 raised to power 3, that is an 8. 1 times 8 plus 1 plus this one times 2 raised to power 2, 4. 1 times 4 plus 0 times 1 3 times 2. 2 raised to power 1 is 2. 3 times 2 plus 1 times 2 raised to power 0 is 1. Any number raised to power 0 is 1 except 0, because 0 raised to power 0 will give us math error. So every other number raised to power 0 is 1. Then plus this value 0. 0 times, now 2 raised to power a negative index will turn to 1 all over 2. So remember one of the laws of indices, we say that a number raised to power negative index is equal to the reciprocal of that number. So we have 2 raised to power minus 1 will give us 1 over 2 plus this value now plus 1 times 1 over 2 raised to power 2. This value now, remember the same rule here that we apply here will also work here, which is 2 raised to power minus 2 raised to power minus 2 will give us 1 over 2 raised to power 2 plus this value 1 times 1 over 2 raised to power 3, which will give us this value now. 1 times 16 is 16. 16 plus 1 times 8, 8 plus 1 times 4 is 4 plus 0 times 2, 0 plus 1 times 1, 1 plus 0 times 1 over 2 will give us 0. 0 times 1 over 2 will give us 0. Then plus 1 times 1 over 2 raised to power 2 is 4. So we have 1 times 1 over 4, that is 1 over 4. Then plus this value 1 times 1 over 2 raised to power 3. 1 times 1 raised to power 1 times 1 over 2 raised to power 3, that will give us 1 over 8. 1 over 8. Now adding these values will give us 20. 16 plus 16 plus 8, that will give us 24. 24 plus 8, 28. 28 plus 1, that is 29. The whole number side will be 29. 29. Then if we calculate this together, we calculate these fractions, we're going to have, okay, let's calculate it together. LCM of these two is 8. 8 divided by 4, 2. 2 times 1, that is 2, plus 8 divided by 1, 8 divided by 8, 1. 1 times 1 is 1. So we have this as 3 over 8. We have this as 3 over 8. So the B says we should convert 3A 5 B base 12 to base 10. So I'll show you using the same expansion method. We also have that take 3 times 12. 3 times 12 raised to power, how many digits do we have at the back of 3? 1, 2, 3. So raised to power 3 plus A 10 times 12 raised to power, how many do you have at the back of A? We have 1, 2 raised to power 2 plus 5 times 12. 5 times 12 raised to power, we have only one digit, which is 1 raised to power plus B times 12 raised to power 0. B times 12 raised to power 0 raised to power 0. That will give us 3 times 12 raised to power 3 plus, now we are working in base 12. In base 12, they normally use, after base 10, we normally from base 11, 12 and so on and so forth, they normally use letters to represent certain numbers so as to avoid mixing up numbers. So A now stands for 10. So A, which is 10 times 12 raised to power 2 plus 5 times 12. 12 raised to power 1 is still 1. Then 12 raised to power 1. Then B, after A, which is 10, B is 11. That means 11 times 12 raised to power 0. Now 3 times 12 raised to power 3, which is 12 times 12 times 12 will give us 1,728 plus 10 times 12 times 12 raised to power 2 will give us 144 plus 5 times 12 plus 11 times 12 raised to power 0 is 1. Any number raised to power 0 is 1. Then equal to 3 times 1,728 will give us 5,184. 5,184 plus 10 times 144 will give us 1,140. 5 times 12 will give us 60. Then plus 11 times 1 will give us 11. So if we add up all of these values together, we'll be having, here's a calculator, we have this value as 6,395. 6,395, and then you indicate your base down here. We've converted this base 12 now to base 10. That is the final answer to B. And then C says we should convert 3, 4, F, 3, 4, not F, is D. Number 2 we have D and then 5. 3, 4, D, 5, base 16. Base 16 is equal to, let's continue step by step. Then we have 3 times 16. 3 times 16 raised to power, how many do you have at the back of 3? We have 1, 2, 3 raised to power 3 plus 4 times 16 raised to power 2 plus d times 16 raised to power 1 plus 5 times 16 raised to power 0 is equal to 3 times 16 raised to power 3 plus 4 times 16 raised to power 2 plus what is d? D is equivalent to 13. D is equivalent to 13. So we have 13 times 16 raised to power 1 plus 5 times 16 raised to power 0. So here we have 3 times 16 raised to power 3 will give us 4096. 4096 plus 4 times 16 times 16, that is 16 square, will give us 256. 256 plus 13 times 16 plus 5 times 1, because 16 raised to power 0, I told you any number raised to power 0 is 1 except 0. 0 raised to power 0 will give you math error. Every other number raised to power 0 is 1. So 3 times 4096 will give us 12,288. 12,288. 12,288 plus 4 times 256 will give us 10,024. 10,024 plus 13 times 16 will give us 208. 208. 208 plus 5 times 1 will give us 5. Now add up all these values together using your calculator. We are going to have 13,525. 13,525 base 10. So 34d5 base 16 is equal to 13,525 base 10. And then the d, last but not the least, the d says we should convert b for f when a base 16 to base 10. Again, we continue step by step. We have b times 16 raised to power 2. We have 2 digits. Let's forget about the decimal point for now. The number before the decimal point, that's what we'll be looking at. So raised to power 1, 2 raised to power 2 plus 4 times 16 raised to power 1. There's only 1 here. Plus f times 16 raised to power 0 plus a times 16 raised to power minus 1 raised to power minus 1. That will give us b is 11. So we have 11 times 16 square plus 4 times 16 raised to power 1 plus f is equivalent to 15 plus f times 16 raised to power 0 plus a is 10 times 16 raised to power minus 10 times 16 raised to power minus 1 raised to power minus 1, right, will give us 11 times 16 square will give us 256 plus 4 times 16 4 times 16 4 times 16 plus 15 times 1 16 raised to power 0 is 1 times 1 plus 10 times 1 over 16 because this 16 raised to power minus 1 will give 1 over 16. So we have 11 times 256 will give us 2,816. Will give us 2,816 plus 4 times 16 will give us 64 plus 15 times 1 will give us 15 plus 10 times 1 over 16, that is 10 over 16. So if you add up all these numbers together, it will give us 2,895. 2,895 whole number 10 over 16. Remember this fraction here, we can reduce it to its lowest term by dividing the two sides by a common divisor, a common number, which is 2. 10 divided by 2 will give us 5. 10 divided by 16. 10 divided by 2 will give us 5. 2 here will give us 8. So we have this value. Okay, implies that 2,895 whole number 5 over 8. So our answer will be 2,895 whole number 5 over 8. Or when you change 5 over 8 to decimal, we are going to have 2,895.625. So indicate your base 10, base 10. So any of them can be the final answer. So thank you very much for watching. Remember, every math genius was once a beginner who didn't quit. Keep practicing, keep believing, and stay tuned by subscribing to Coach Calculus. The world must see the genius in you. Have a nice day.